I'm going to work on the 10.4 polar graphs assignment, and I'm actually going to just do two problems from each objective, uh, all in one take, just because I think it'll be a little easier to do. So we're going to start with the first objective. And it says graph a circle or a line from a polar equation. Now, one thing I want you to understand is they give you this graphing software that makes this process a lot easier. If you were doing this by hand, we'd do the same process that we're about to go through, but we would just include more points. So you'd actually need to graph um, this equation with theta being 0 degrees, uh, pi over 6, pi over 4, pi over 3, pi over 2, all the way around the unit circle. You need to use every angle on the unit circle to really get a good depiction of what the graph looks like. Because they kind of set us up with what the graph looks like beforehand, we can be specific with which points we're going to plug in. So that's what I'm going to do in this objective and throughout this assignment. So I'll start with r equals 3 sine theta, and over in Desmos, I'm going to plug in 3 sine, and anytime there's just theta written here and there's no leading coefficient on it, I'm basically just going to use 0 degrees, pi over 2, we'll use pi, and then we'll say 3 pi over 2. And you'll notice that we get 0 for when we plug in 0. So this is our radius at 0. So this is our angle, this is our radius. Pi over 2 has a 3 for radius. Remember, we have r equals 3 sine theta. We're working with polar coordinates. And then we have pi is 0, and then we have 3 pi over 2 is actually negative 3. So we're going to go down here, and we're going to start graphing this thing. And you can make it look, you know, quite a bit different as we go throughout this assignment. There's a lot of different looks to these cardioids and the other functions that we end up with. So I want to graph this. I get pi over 2 is 3, so I'm going to make sure that I go to pi over 2, and I want my value to be 3. So I'm going to put 3 at pi over 2. It says that pi should be 0, so if I go to pi, I get 0. If I go to 0, I get 0 as well. If I go to 3 pi over 2, it tells me my radius is negative 3, which means I need to go to the opposite side, so I get this point here. So I have the correct graph here. It's got a radius of 3, and my point 3, or my radius of 3, it happens at pi over 2. So I have the correct graph. And then they give us 5 sine of 4 theta. And this one's going to be a little bit different because I have this leading coefficient, which is 4 theta. So I'm going to change these up a little bit. I'm going to say 5. Actually, I'm going to say 5 sine 4. Now, the first thing I'm going to plug in is I will plug in not 0, but because I have a leading coefficient of 4, I'm going for sine of pi over 2, because I know sine of pi over 2 is 1. But I can't use pi over 2 here because I'm multiplying by 4. So I need to use something different. I'm going to use pi over 8 here to get this so that it's actually pi over 2. And then I'm going to use versions of pi over 8 throughout this. And I'm going to say that 4, and this will be parentheses, I'm going to use, 2 pi over 8. And actually, I'm not going to use 2 pi over 8. I'm going to use 3 pi over 8. I want to use odd powers. If I use 2 pi over 8, that's just pi over 4, and they'll cancel, and I'll end up with 0. So we're going to say 3 pi over 8. I'll copy this. This will be 5 pi over 8. 7 pi over 8. We need to take it times 4. And you'll notice we're going back and forth a little bit here. We got 5, -5, 5, then all of a sudden we get -3. Oh, but that's only because we have a 3 there. That should be 5. Okay, 5, -5, 5, -5, so on and so forth. So let's go ahead and take a look at what we have options for with our graph here. So how many petals do I have? Well, this 4 that's the leading coefficient here tells us that I'm going to have a certain number of petals on this. Anytime you have an even coefficient on the inside on theta, that means you're going to essentially double the number that's written there. So 4 times 2, I have 8 petals. Notice I've only gone around, I haven't even gone around pi times on this circle yet. So I'm going to keep going and do this a total of 8 times. So I'm just going to paste this 4 more times. And then we're going to go up. This is 9. This is 11, 13, and 15. And so you'll see that we're getting petals here because we're going back and forth between 5 and -5, 5 and -5, 5 and -5. And if I go in between and I use 10 pi over 8, I get 0. So I'm getting a bunch of these petals. And there's 8 of them total. And I can get that by just taking that number that's the leading coefficient and taking it times 2. Now, if it's an odd number, we don't multiply it by 2. We just work with that number that's out front. So if that's a 3 there, we'd have 3 petals. If it was a 5, we'd have 5 petals. But if it's even, we have to double it. So I am getting pi over 8 and 5. Now with the software, you really only need one of these petals. So pi over 8, that would be, let's see, pi over 4 is here. So pi over 8 is half of that, which would be right here. So we're in a good spot. And I need this point to be at 5. Well, this is 2, this is 4, so 5 would be right here. So I'm going to grab and drag that out to 5. And that's what my graph should look like. This is a rose petal. Now we're given r equals 4 cosine 2 theta. And again, we have an even number here, so we're going to end up with 4 petals there because 2 times 2 is 4. Let's go ahead and take that equation. Cross all these out. I got quite a few of them. We'll take that equation. We'll say 4 cosine 2, but I'm going to not use, usually I'd use 0 here. I'm going to use, well, I'll probably use 0. That's fine. We can start with 0. But then I'm going to use pi over 2. I can use, because it's cosine, I can go ahead and use pi over 2. If it were sine, I'd do something different, but for cosine, I'm going to just keep using pi over 2. And then we're going to say 4 cosine of pi, so 2 times pi. And then 4 cosine of 2 times 3 pi over 2. And so what we get here is we're getting 4 when we're at 0. So let's go ahead and mark this. And we have how many petals? I said earlier we had 4 petals. So we need to increase the number of petals. There's 4 petals. It's a cosine graph, so notice sine was kind of at an angle. Cosine is actually along the axes for the most part. So we're in a good spot there. And 0 is 4. So 0 degrees, I have a radius of 4. So I'm going to go ahead and grab and drag this radius down to a radius of 4. That's 10, 8, 6, 4. So this should be my rose petal this time. And I can tell because pi over 2 here is giving me -4. Pi is giving me 4. So I'm getting all these points for my petals. Like I said at the beginning, if you're doing this by hand, you would plug in a lot more points than this. You would use every coordinate on the unit circle. Now we're given 6 cosecant theta. So 6 cosecant theta is a little interesting. In fact, cosecant theta and secant theta are interesting. So we're not going to get a chance to do a secant theta. We're just going to be able to do cosecant theta here because we're going to actually pass this objective after this problem. But cosecant theta is going to give you a horizontal line, and secant theta gives you a vertical line. And secant theta gives you a vertical line for the same reasons that I'm about to explain for cosecant theta. Okay? So we're going to go up here, and we're going to apply this logic to cosecant, but it also applies to secant as well. So we're going to say 6 cosecant, and I'm going to start at 0, and it's undefined. I'm going to say 6 cosecant of pi over 2. And actually, I'm going to go around, I'm going to do pi over 4 just for fun, because it's going to help make my point for cosecant and secant. We're going to do 6 cosecant pi over 2, 6 cosecant, we're going to do 3 pi over 4. And then after this, I'll just do 6 cosecant of pi, and then 6 cosecant of 3 pi over 2. All right. When we're at when we're at 0 degrees, we have an undefined radius, so it's not defined there. I'm going to ignore the pi over 4 and the 3 pi over 4 for now. I'm going to go to this pi over 2. It says pi over 2, we get 6. So we're going to go ahead and make sure that this says 6. So pi over 2, we get 6. 3 pi over 2, we get -6. So if I go down here to 3 pi over 2, I'm getting -6, which would be up here. Now, we're going to go to the pi over 4s. The pi over 4 is 8.4. Pi over 4 is here. And let's count from the middle. That's 1, 2, 3, 4, 5, 6, 7. Did I miscount? I must have miscounted. Let's see. 1, 2, 3, 4, 5, 6, 7. And then, oh, I didn't miscount. It's not a flat line yet. Let's flatten this out. Oh, when I flatten that out, I need to move that back to 6. 1, 2, 3, 4, 5, 6, 7, 8.3 or 8.48 would be about right there. So notice that when I got pi over 4, I'm actually still on this horizontal line here. And the same thing's true if I do 3 pi over 4. 3 pi over 4, I got 1, 2, 3, 4, 5, 6, 7, 8.48. So no matter what angle I plug in, I'm going to get a value for the radius that's going to equal a point on this horizontal line. That's going to be true for secant as well. So secant and cosecant, when you're graphing with polar coordinates, are going to give you straight lines. All right, now we're going to graph a limescate from a polar equation. Now these ones are a little bit different because they are equal to r squared. So we're going to, we're still going to plug in the same coordinates that we typically do, but they act just slightly different because of this r squared. Now, I do have a 2 that's out front, but this does not necessarily give you, it gives you these 2 petals right here, but it's not the same as the rose graph because of this r squared piece. So we're going to go ahead and say, I guess the r squared piece would give you half the petals. So this would usually give you 4. It's giving you half the petals. So we're going to say negative 25 cosine of 2. This time I'm not going to plug in, I might still want to plug in 0. Let's see. Yeah, we'll plug in 0, but then we're going to plug in pi. And notice both of those are giving you negative 25. Well, I have r squared here, so the radius squared is equal to negative 25. Both of those are undefined. So these two values, 0 and pi, will not work. So I'm going to plug in pi over 2. Pi over 2. We're going to do negative 25 cosine of 2 times pi over 2. This time I get positive 25. And if I did the same thing for like 3 pi over 2, I get the same value, 25. Now, when r squared is equal to 25, I square root each side, I get r is plus and minus 5. So technically at this angle of pi over 2, I'm going to have a radius of 5 and a radius of negative 5. So let's go down here and let's go to pi over 2. So we'll grab and drag this around to pi over 2. I need a radius of 5, which would be right here. And then I also need a radius of negative 5, which would be on the opposite side. And notice that 3 pi over 2 is giving me the exact same value, 25. So it needs a radius of 5, but then also negative 5. So we're getting these 2 points. And so this lemniscate they're fairly easy to solve. You just have to figure out, you have to rule out the pieces that won't work because of the r squared. Now we're going to graph a limacon from a polar equation. So they give us 5 sine theta plus 8. We can go ahead and type in 5 sine, and I'm going to start with 0 plus 8. And then 5 sine of pi over 2 plus 8. I'm going to copy this so I can do it 2 more times. We're going to do 3 pi over 2, and then we'll also do just pi. Okay, so you're getting 8, 13, 8, and then 3. So let's graph these and see what happens. If I go to 0 and I graph 8, so 0 should give me 8. Actually, because it's sine, I need to graph probably this pi over 2 piece first. Pi over 2 tells you 13. So let's go ahead and mark 13 up here. So we got, let's see, that's 12, that's 13. All right, we're going to mark that one first because that'll help set everything else up. I need to have 0, 8. So 0, 8 for radius, good. I've got pi, which is 8, so I go to pi. I got 8. And then I go to 3 pi over 2, and I should have 3 pi over 2. I do have 3 there for the radius. So I've got this thing graphed, and again, all I'm doing is I'm plugging in coordinates, just making like a t-chart. Okay, we have another lemniscate that I'm going to graph. So I'm going to take this negative 49 cosine 2 theta, and I'm going to plug that in. So I've got negative 49 cosine of 2, and I'm going to use, again, pi over 2, like I did in a previous example. And that gives me positive 49, so that's good. So I'm going to use 3 pi over 2 here. Which also gives me positive 49. Well, that means that r squared is equal to 49. So then that means the radius, if I square root each side, would be positive 7 and negative 7. So let's go to pi over 2 and then mark this at positive 7. Should be right here. Yep. Yeah, 5. Well, no, up one more. 7's right there. So positive 7 for pi over 2, but then also negative 7. And so the limescape is pretty easy to graph because all you have to do is find a value that is positive and then take the square root of that, and you'll get your two values for your two petals. Let's see how far we got. Oh, we still have to graph the rose curve and the cardioid. Okay. So we're going to graph a limacon here. And we have negative 5 cosine theta minus 9. So we're going to plug that in over here. Negative 5 cosine. And instead of using theta, I'm going to use 0. And then I'm going to plug these in. So I end up with pi over 2. I'm going to use pi. And then 3 pi over 2. And you'll notice that at 0 degrees, I should have negative 14 for a radius. So 0 degrees would be over here. So negative 14 I need on this side. Let's grab and drag this one over. That would be negative 14. I need pi over 2 to be negative 9. So if I go to pi over 2 and then go the opposite, negative 9, I do have that. Pi, if I go over here, this would be pi. But it says negative 4 for radius, so I go to the other side. I'm at negative 4. So I have the correct graph here by plotting points. Now I'm going to graph a rose curve from a polar equation. And this rose curve is going to have, if you look at the 2 there, that's going to have 4 petals because we take the leading coefficient times 2. Now to get the 4 petals, I'm going to need to plug in specific coordinates. And my specific coordinates are going to be 4 sine of 2, but I need to multiply by, I'm trying to get sine of pi over 2 here, but I can't just use pi over 2. I need to, because I'm multiplying by 2, I need to use pi over 4 to get pi over 2 in there. And then I'm going to do the same thing. So I'll copy that. Remember I said I had 4 petals. So I have 3 pi over 4 is one of my petals, 5 pi over 4 is one of my petals, and 7 pi over 4 is one of my petals. Because once I find the first one, which I said the radius is 4, I know I've got 3 other ones that are going to be, basically I'm looking for sine of pi over 2 over and over and over again. Pi over 2 or 3 pi over 2. And this gives you 3 pi over 2. This ends up giving you, well, it'd give you 5 pi over 2. And this ends up being 5 pi over 2, remember, is pi over 2. So we're getting those same values over and over and over again. So let's go ahead and graph these. So we go back and we say we need 4 petals, but we should be at pi over 4, we should get 4. So pi over 4 is here. We should have 4 on the graph. Notice these are not in the right spot, so I'm going to switch the symmetry. All right, pi over 4, we're in the right spot now, and this should be at 4. Well, this is 2, 4, 6, 8, 10. Yeah, so this is 4. So this is the correct graph because I've got pi over 2 and 4 there. I've got 3 pi over 4, and 3 pi over 4 would give you negative 4, which is back here. 5 pi over 4 is here, and it's supposed to give you a positive 4, which will be that spot. And the 7 pi over 4 gives you a negative 4, which is this other leaf here. And then we're going to graph a cardioid from a polar equation. So to graph this cardioid, I'm going to write 5 sine of 0 plus 5. And I'm going to copy that 4 times. Notice there's no leading coefficient on theta. So I'm going to write this as pi over 2. This will be pi. This will be 3 pi over 2. And I'm getting 5, 10, 5, and 0. So we'll go to this pi over 2 value and we'll graph this 10 for the radius. Pi over 2 is here. So I need to switch to the symmetry. And then I need to graph 10 for my radius. Make sure these other match up. I got 0 should be 5 for radius. So 0, 5. I should have 3 pi over 2, 0. So 3 pi over 2 is down here. 0. That's, yep, we got that for a radius, 0. And then also we've got pi, which should have a radius of 5. So that's my cardioid. Okay, graph another rose curve. And again, we look at the leading coefficient, which is 2, so that tells us we have 4 petals. I'm going to switch this to the correct number of petals. And then I'm going to take that equation and plug it in over here. So it's negative 16 sine of 2. This will be, I'm going to use pi over 4 here. Because again, I'm trying to get, because it's the sine function, I'm trying to get pi over 2 on the inside. I get negative 16 there. And because I know I have 4 petals, I'm going to use different versions of pi over 4, which would be 3 pi over 4, 5 pi over 4, and 7 pi over 4. And those are going to give me my 4 petals there. You can see it's negative 16, 16, negative 16, 16. So I'm going to switch my symmetry because I need to be at pi over 4, and these are now at 0 degrees, pi over 2. I need to switch the symmetry so that it's at pi over 4. Now, pi over 4 needs to have a radius of negative 16. So I'm going to grab and drag this till I get negative 16, which it looks like I'm already on negative 16, right? This is 10, 12, 14, 16. This is actually positive 16. So if I went to the other side though, right, I'm looking at pi over 4, negative 16, that would be this point here. If I go to 3 pi over 4, it's right here, I get positive 16, that's that coordinate. If I go to 5 pi over 4, which is this spot here, I should get negative 16, which I do. And then 7 pi over 4 should be 16. So I have my rose curve. And this will be the last problem that we do. This is a cardioid. And so we'll just do like we've done with these other cardioids, and we're going to plug in 2 cosine theta. But I'm going to say 2 cosine of 0 minus 2. And I'm going to copy that, and I'm going to do pi over 2, pi, and 3 pi over 2. So I end up with 0. So 0, 0. Okay, that's good. Pi over 2 should give you negative 2. So pi over 2 should give you negative 2. It's not doing that yet. Let's look at pi though. Pi should be negative 4. So if I go to pi, I should get negative 4. So I should be on this side. I need to grab and drag this to the other side. So pi should be negative 4. It is. Then I'm going to look at that pi over 2 situation. So pi over 2 is supposed to be negative 2. It is. 3 pi over 2, which would be down here, should be negative 2. It is. And then obviously they say that 0 should be 0. And it is. So we're good. We're good there. Yep, we are good there. Let's submit that. So we've graphed a bunch of these different equations. The one thing I want to stress to you is if you were doing this by hand, just like I said at the beginning, you would just go through and you'd plug in all of the angles on the unit circle and evaluate each of the functions at those angles, and then you'd plot those points. And that's what all I'm doing here, except for they kind of make it easy because they already have the graphs made. So I'm just plotting specific points that will help me get the detail I need to put this into the Newton software.